welcome to Coding with Marcia. Today we will talk about libraries. Python is a popular language, and it's mostly because it has a lot of libraries, or you can also call it packages, that have reusable code within. A library or a package is nothing but a collection of related items, related coding modules. For example, you can find their functions, you can find their data structures, you can find their variables, or you can find their classes, for example. These bundles of code can be repeatedly used in your projects so that you don't have to reinvent the wheel. The purpose of libraries is to make the code more reusable and to save time for the programmer. In other languages such as Java or C#, you have similar concepts. There are many libraries, but today I'm going to talk about 6 of them that are the most important. So I will talk about numpy, pandas, matplotlib, sklearn, tensorflow, pytorch. Let's start with numpy. Numpy is a library that allows you to deal and to handle arrays in an efficient manner. It is the #1 package in Python, mostly because all the other packages also use numpy underneath. You can also use it for linear algebra, Fourier transform, general signal processing, and also random number generation. Pandas is another package that is really useful to deal with tabular data. What is tabular data? Well, it's data that is generally heterogeneous. It contains heterogeneous types of data, and it has rows and columns in it. So it has the form in the shape of a table. That's why it's called tabular data. Pandas also has many functions to deal with time series data. If you don't know what time series is, it's just a collection of data that changes over time, so it's connected to the temporal dimension. Pandas is especially handy to use when you want to prepare data, or you want to mix data or merge data, combine data. So it's very often used for pre-processing data. Matplotlib is a library that allows you to visualize data, to plot histograms, bar plots, error charts, heat maps. And the good thing about Matplotlib is that it is intuitive and very rapidly you can get a plot. There is also other libraries for visualizing data. One of them is sklearn, which I really like because it has a more elegant look to it. But because it's more difficult to do certain specialized things in sklearn, you usually resort to matplotlib for most visualizations that you do. Then you have sklearn, which has a wide range of machine learning models, so not just neural networks, but random forests, support vector machines, nearest neighbors, and so on. And it's a good start in machine learning to use this library. TensorFlow is from Google, and it's a library that allows you to program really complex neural networks. So it's in the realm of deep learning. Because the syntax of TensorFlow is a bit complex, sometimes you use an API, on top of it, so that it simplifies your coding. And one of those very famous APIs is Keras. Keras allows you to write code that gets translated into TensorFlow code in a much simpler and faster way. To deal with deep learning, you have not only TensorFlow, but also other packages, other libraries, such as, for instance, pytorch. I am now going to show 3 examples of code of numpy, pandas, and matplotlib. I will not show examples of code of the deep learning and machine learning libraries because it's too complex and you would probably have difficulties understanding all the details of the models. So now that we are in the PyCharm environment, in the Python environment, we can look at this example of coding with numpy. So first I import the numpy, and then I define two arrays, array 1 and array 2. And then I print the type of the elements in array 1 and the type of the elements in the array 2. Let's see. Okay, so now I know that my array 1 is composed of integers, and the type of objects in the array 2 is floats. This is an example of how you can create arrays using the numpy library. Second example, we are now dealing with the pandas library. So I first import the pandas library, and then I read data from a CSV file that has data about airports, the delays in airports. And then I will first print the names of the columns in the data frame, and I will then show the contents of the data frame, its first 5 rows. So let me do this. Okay, cool. So first thing, my new data frame has all these columns names. So it has the code of the airport, the name of the airport, the time, the month, the year, the number of delays of certain carrier, and so on. And we have here the data frame. So as you can see, you have the index 0, 1, 2, 3, 4. I'm just showing 5 lines. Then you have the code of the airport, then you have the name of the airport, and so on. This is to show you how you can use very simplistically the pandas package. Third example, we are going to talk about matplotlib and also sklearn. So here's the imports that I need. I'm going to read the same CSV than in the pandas example, and I'm going to print the density of the number of delays per airport. I'm going to do this in matplotlib, and I'm going to do this using code for the sklearn. You can see right away that the code for the sklearn is much smaller, but in certain cases it's very hard to do certain advanced things with sklearn. But in general, it can be more cohesive than the matplotlib code. So let's see. It takes a while because it's reading the data. Okay, and now you see you have the delays per airport. We're just considering 5 airports, and we are considering the distribution of the delay time. And now we also have the density shown by the sklearn. So I think personally it's more elegant. It's has a better output than the matplotlib. Now we are going to talk about importing libraries. The first thing that you need to know about importing libraries is that it's not possible to import a library unless it's installed in the system. How do you install it in the system? Let's see. First, let me try to import a package that is not installed. sklearn. It's gonna give an error. As you can see, it says no module named sklearn. What you can do is you go here and you select install package sklearn. It takes a little while, but then you have the package installed. In case you want to install your package in a different way, you can go through the settings. So you go here, settings, you choose Python interpreter. This is all the packages that you have installed in this environment, and then I'm going to click add. I'm going to search cbar. Okay, it's here. I could even specify the version, which is really useful for TensorFlow packages, for example. And then you could, I'm just going to leave it the default version, and I'm going to install the package. Takes a little while, but it's installed successfully. Okay. So other packages that you can import is, for instance, pandas, or numpy, or matplotlib. But when you import matplotlib, it's quicker to access all the functions through pyplot, which is a sub-package. So you can write something like matplotlib.pyplot.plot, for example. Now I'm going to talk about an important mechanism in Python, that is aliasing. Sometimes you don't want to always write and type the entire name of the packages and sub-packages that you want to use in your code. And for that reason, you have something that is the alias name. So for instance, for seaborn, I could call it CNS. For pandas, I can call it pandas. For numpy, I can call it PT. This is usually, what people use, but you can give any other name, as we will see. Sklearn, I don't usually put an alias, and tensorflow, I usually call it TF. This allows you to do something like this. So numpy, instead of numpy, I write np, and I can access any function that's inside the numpy package this way. So I can call the mean, for example. Okay. If I were to call a different name to the, if I were to give a different alias, such as for instance cookies, I could also use it. So cookies dot mean, it would work. Okay. So, but for clarity, we usually use np. So, but you can give any name, as I have referred. Okay. So, sometimes you also do not want to use the entire package. You just want the function, and to avoid the burden of having to import everything, you can do something like from numpy import the mean, and then instead of using np.mean, I can use directly the mean name. Okay. So far so good. A final note is the help function. The help function is useful because it allows you to have information immediately about a function in Python without having to go to the forums or leave the environment, the Python environment. So for instance, if I want to check npmean, I can run it, and then you have information about the function mean. You have the parameters, the returns, what you need to input, what you'll get as output, and also some notes, some information that is useful, such as for instance in single precision mean may not be accurate, and it's better to use the mean in float 64. You can check the examples later on. So that is all for today. Thank you for watching, and see you next video.